So let's start with some trigonometric graphs. Now there are three main graphs that you have in your syllabus. You know which ones? Do you know the three graphs that you have in your syllabus? Sine, cos, tan. Okay. So graphs of trigonometric functions. Sin x, cos x, and tan x. Okay. Now, as it is with any new concept, initially it's difficult. Initially, you feel like it's overwhelming, but with practice and gradually, you get the hang of it. Okay. Now, it's very important for you guys to have the basic shape of sin x, cos x, and tan x memorized like the back of your hand. Okay. So the graph of sin x looks like this. All right. Now we will do it in detail. Okay. The graph of cos x looks like this. Again, we're going to do this in detail as well. Don't worry about it. The graph of tan x is slightly complicated. This is what it looks like. Okay. So we're going to do all of these in detail, so you don't have to worry about it. But yeah, you should have the basic shape memorized. Yes, Aruj, of course, there is you have these three graphs in your syllabus. Okay. Now, IGCSE students might have some understanding of these graphs, okay, and AdMath students definitely would have like a very deeper understanding of these graphs. So if you do, that's great. You have a slight edge. If you don't, there's nothing to worry about. Okay. Tan is out of yeah, tan is slightly weird. Fair. Anyway, so let's start with y equals to sine x. Okay. Now, as it is with solving trigonometric equations, with trigonometric graphs also, you have a certain range. Okay, you have a certain range of x. Now, you have this with every graph related question there is. Even if you go back to O levels or IGCSE, when you were doing graphs of functions, you were told that you should take values of x starting from maybe -3 or 2, or maybe the table was already drawn for you. All you had to do was first plug in the values of x to find out the corresponding y values, and then mark those values on the graph and then draw it. Okay. So here also, although you will not have the table drawn, but you will have to draw the table yourself. Okay. So we have the range of x is from 0 to 360. Okay. Now, normally in, let's say, a quadratic curve, or in, let's say, if you're making an exponential curve or a cubic curve, we plug in integer values. Okay. We plug in 0, 1, 2, 3, 4, 5, all the way to the very end. Or maybe we skip one value, like, for example, 0, 2, 4, 6. But what about trigonometric graphs? What do you think? Scroll up to what, Marjan? This or the homework questions? Done? Okay, brilliant. So here, if we start from 0, then that's not a good idea. Why is it not a good idea? Why is it start? If we start from 0 and let's say we plug in values from starting from 0, 1, 2, 3 with a difference of 1, that's not a good idea. Why is that? Here's x, here's y. Mm-hmm. Sorry? No, no, we will plug in 0. But what's the value that we should plug in after 0? Should we plug in 1, 2, 3, 4, 5, all the way to 360? If we do that, then we won't have time to do anything else in the paper. So what we do is we take a step, okay? And the step that we normally take in the case of sine and cos is 90 degrees. In some cases, we take 45 as well. But the step that we normally take in the case of sine and cos is 90 degrees. Now, what does that mean? What does step 90 degree basically mean? That means we're going to plug in values after every 90-degree interval. So if you start from 0, the next value that you're going to plug in is going to be 90. Okay. And then the value after that is going to be 180. Now, why do we pick these values in particular? You might ask, I mean, where exactly are these values coming from? That's because if you look at the shape of sine x, you will see that at these values, we get integer results. Okay, so that makes it easier for us to draw the curve. All right. Now, you can do 45, 90, 135, 180, 225, 270, 315, 360. But then in between, like for example, at 45, at 135, you will have non-integer values, which will be difficult for you to mark. And hence, it will be difficult for you to make the graph. Okay, so here's 90 here, and then 180, then 270, then 360 degrees. Now, I want you guys to take out your calculator and plug in these values for me. What is sine 0? 0. Good job. What's sine 90? 1. What about sine 180? 0. Sine 270? What's sine 270? Minus 1. And sine 360, if you work it out, you'll notice that you get 0 again. Okay. Now, with the help of these values, let's make the graph of sine x. Okay. So what's the maximum value? The maximum value you can see is 1. What's the minimum value? The minimum value you can see is minus 1. Okay. And we have taken values after every 90-degree interval. Okay. So if this is 360, here's 180, here's 90, and here's 270. Remember, we're making a sketch. Okay. We're not plotting. We're just making a sketch. So I'm going to mark all the points now. At 0, it's 0. At 90, it's 1. At 180, it's 0. At 270, it's minus 1. And at 360, it's 0 again. So this is what the graph of sine x looks like. There you go. Okay. Here's your x-axis. Here's your y-axis. Now, a couple of things you should know about the graph. What do you think will happen if I didn't stop at 360? What do you think if we went on and found out sine of 450, 540, 630, 720? What do you think will happen? Yes, we will get the same pattern. It's going to repeat. Okay, so if let's say you didn't stop over here, what will happen is that the cycle will repeat. So you'll get the exact same shape again. Oops. Copy, paste. So, and then after 720, you will get the exact same shape again. Okay. So where do you think one cycle ends? At what value of x do you think one cycle ends? Yes, at 360 degrees, you have your first cycle. First cycle ends. Okay, and this cycle after that would end at 720 degrees. And then after that, another 360. Okay. So a couple of things to remember over here. A couple of things to note over here, in fact. What's the maximum value? The maximum value is 1. What's the minimum value? The minimum value is minus 1. Okay. So what do you think will happen if, let's say, we try and solve an equation sine x equals to 2? Try and take sine inverse of 2. Tell me what you get. So if you take sine inverse of 2, make sure your calculator is in degree mode. You get a math error. Now, can anyone explain why sine inverse of 2 is a math error?
Maximum value of sine is 1.
Very good. It's a math error because you can see now that sine x can only be equal to 1 or minus 1 and everything in between that. So the range of sine x is basically in between 1 and minus 1. So anything more than 1, sine x can never be equal to that. Anything less than minus 1, again, sine x can never be equal to that. Okay, so that's the reason why if you try and solve a trigonometric equation such that the constant is out of its range, that's why you get a math error. Okay, now there is something which we need to know the formula of, and that is amplitude. And what's the formula for that? It's maximum value minus the minimum value divided by 2. Now, don't worry about where we're gonna use use all these formulas and what exactly will the question look like. At the moment, just focus on the concept. How does sine exist? Oh, okay. So what's the maximum value? The maximum value is 1. What's the minimum value? It's minus 1. Divide that by 2. So what do you get? You get 1. Okay. So the amplitude is equal to 1. And amplitude is also something that can be seen by looking at the equation. It's the constant that is being multiplied by the trigonometric function. Okay, but more about this later. I want you guys to make this a standard rule that whatever sine x is being multiplied with will always be equal to the amplitude. Sometimes it's different. Okay, so we'll learn more about that. At the moment, I want you guys to remember this formula only. Okay, then there is something called the natural period. Now, natural period, by definition, is basically the number of degrees it takes to complete one cycle. So how many degrees does it take? Sine x to complete one cycle, it takes 360 degrees. So that is why the natural period of sine x is equals to 360. 360 degrees or 2 pi. Okay, or 2 pi radian. All right. So what does one cycle look like? This is what one cycle looks like. This is 0 and this is 360. Okay, after that, it's the exact same pattern again, which means it's the next cycle. All right, so this is what the graph of sine x looks like. Take a good look at it. Let me know if you have any questions. Don't worry about what actual questions will look like. We'll get to that. But so far, if you have any questions, any confusions, please feel free to ask. Okay, great. Now, next is cos x. Y is equals to cos x. So we're going to make the exact same table. Sir, will we do, yeah, so we'll do transformations when we're doing, so we'll apply transformations to these graphs as well, and we will formally do transformation of functions when we're doing functions. So the reason why I prefer doing trigonometry first and functions later is you have a good understanding of transformation, and then when you do it formally, it makes more sense. And you also then have a good understanding of range. That's why I prefer doing trigonometry first and then functions after. Okay, so for cos x, we're going to do the exact same thing. All right. For cos x, we are going to start from 0 and then plug in values after every 90-degree interval. So here's 0, here's 90, here's 180, 270, 360. Okay, and I want you guys to find out the corresponding values. So cos 0 is 1, that's correct. What about cos 90? Cos 90 is 0. Cos 180, minus 1. Cos 270, 0. Good job. And cos 360, 1 again. So let's see what the graph will look like. So here's 360, here's 180, here's 90, and 270. 1 minus 1. So at 0, it's 1. So that means this is starting from 1. It's not like the graph of sine, which is starting from 0. And then at 90, it's 0 again. At 180, it's minus 1. At 270, it's 0. And at 360, it is 1 again. Okay. So now let's make a nice and smooth curve. So this is what the graph of cos looks like. And as always, with as we saw with sine, if we didn't stop here, if we continued, if we went on all the way to 720, we will get the exact same shape again. Okay, so if let's say I didn't stop here, I went on, we would have gotten the exact same shape again. Okay, which is why the natural period of cos x is also 360 degrees. Okay, so here's x, here's y. What's the maximum value? The maximum value is 1. What is the minimum value? The minimum value is minus 1. And what is the amplitude? The amplitude is equal to 1. And what is the natural period? The natural period is 360 degrees or 2 pi radian. Okay. Now, as always, take a good look at it. Let me know if you have any questions more about the graphs later. Like I said, right now we are just we're just familiarizing ourselves with the basic shape, and then we're going to apply some transformations to these later on. Okay, now let's do tan. Y is equals to tan x. Now tan x is slightly tricky. Okay, the graph of tan x is slightly tricky, but you'll get the hang of it. Okay, with practice you'll get the hang of it. 0, to 360 degrees. Okay. Now with tan, what we do is we change the step slightly. Okay. And what do we mean by step? Step, remember, I will be using this word very often, so I want everyone to fully understand what I mean by this. Step is basically the interval after which we're going to plug in values. So in the case of sine and cos, the step that we opted for was 90. In the case of tan, yes, the step that we're going to opt for is 45 degrees. So 0, 45, 90, 135, 180, 225, 270, 315, and then finally 360. Now, there is a way through which you can do this using your calculator. I don't know if you guys are already aware of it. I've made videos on it as well, where you can make a table in your calculator and find out where your calculator will basically plug in the values for you and give you the end result. Okay, so if you know how to do that already, that's great. If you don't, I am pretty sure I have a video on it, which I'll share with you guys. Okay. All right, so let's start with 0. Why 45? Okay, the reason why we go with 45 is because if we go with 90, okay, so let's do one thing. If we go with 90, the thing is we are unable to understand what the shape is. Okay, so let's just plug in values with the interval of 90 degrees so that you find the answer to your question. If you plug in 0, you get 0. Okay, if you plug in 90, tell me what you get. What's tan 90? Make sure your calculator is in degree mode. Tell me what is tan. Yeah, you'll get an error. Okay, so basically we'll learn more about this error. So at the moment I'm just going to write E. Then if you plug in 180, you'll get 0 again. Then if you plug in 270, you will get an error again. And then if you plug in 360, you will get 0 again. So by these values, is it possible for us to understand what the graph is going to look like? Because all we have are two. In fact, we just have one value, 0. Okay, because error, we can't really tell what this value is. Okay, so that is why what we do is we add a value in between. Okay, and and the value that we add is 45. So find out tan 45, you will notice that's 1. Find out tan 135, you will notice that's -1. Find out tan 225, you'll notice that's 1. And tan 315 is -1. But the thing is, still, you might argue that even this information is not enough for us to understand the shape of the graph of tan. So what we're going to do is we're going to go the extra mile. Okay, we're not going to do this all the time. We're just doing it right now so that we understand how it works. And then we'll just stick to the bare minimum. Okay, so at 0, it's 0. At 45, we can see it's 1. At 90, basically what happens is the graph goes towards infinity. Okay, so what happens at 90 is that the graph goes towards infinity. Okay, and what we do is we draw these dotted lines to show that. Now there's a name for these dotted lines. You guys know what these lines are called? There's a special name for these dotted lines. Yeah, so they're called asymptotes. Now it's a fancy word for something very simple. What are asymptotes? Asymptotes are basically infinite dotted lines. Okay. Now, sometimes we physically draw them, sometimes we don't, in which case they're imaginary. Okay. But what they are is they're basically infinite dotted lines to show that the curve is going to get closer and closer to this line, but it's not actually going to cut it. Okay. And we're going to see that in action. So, what I want you guys to do is I want you guys to keep your calculator ready. At 90, it's infinity. Okay. But what I want you guys to do is I want you guys to work out tan 89. Tan 89. Tell me what you see. Let's do it together. Tan 89, what do you see? 57.3. Okay, good job. 57.3. Okay, no need to write down the exact value, just the approximate value will do. Okay, because we're sketching at the end of the day. Now work out tan 89.9. What do you see? Tan 89.9? 573 approx. Yeah, 572 point something, 573. Now work out tan 89.999. 3 nines after 89. Tan 89.999. So you will see 57,295 something. Okay. So What exactly is going on? What's happening as the graph is getting closer and closer to 90? What do you think? Yes. So as we're approaching 90 degrees, what's happening is the graph is getting closer and closer to infinity. Okay? It's getting larger and larger. And what happens at exactly 90? At exactly 90 it becomes infinity. Okay? So as it's approaching 90, it's becoming larger and larger, but the second it's equal to 90 it becomes infinity. Okay, which is why we draw it like this, parallel and infinity. Yeah, so it basically what happens is as it's getting closer and closer to 90, this by the way is drawn on 90 degrees. So let me do this again. So at 0 it's 0, at 45 it's 1, and then what happens after 45? It starts to increase, and the increase is very rapid. Okay, the increase is extremely rapid, which is why what happens is the graph becomes almost vertical. It's not exactly vertical because it's the curve at the end of the day, but it becomes almost vertical such that it seems as if it's parallel to the vertical line that we have at 90 degrees. Okay, so just before 90 it's an extremely large value, okay, which we saw at tan 89 and tan 89.9 and tan 89.999. But the second we have tan 90, what happens is it becomes infinity. Okay. Now, what happens after 90 degrees? That's another story. What happens after 90 degrees? So, what I want you guys to do now is I want you guys to find out tan of 90.1. Yeah. Work out tan of 90.1. Tell me if you get a value. Yes. So, tan of 90.1. So you'll notice that the values are more or less the same except that they're now negative. So tan of 90.1 is equals to minus 572. Now work out tan of 90.001. 90.001. What do you see? Minus 57,295. So what exactly is going on over here? What happens right after 90? Larger value and negative. Yes. So basically, infinity can be of two types. It can be positive infinity and it can be negative infinity as well. Okay. When something is extremely large and positive, it's positive infinity. And when something is extremely negative, it's negative infinity. So just before 90 degrees, it was approaching positive infinity. But right after 90 degrees, it approaches what? It approaches negative infinity, and then it comes back from negative infinity. And what is it equal to at 180 degrees? At 180 degrees it's equal to 0. So that means after 90 degrees this is what the graph looks like. And before that, in between that, we have another value. Sorry, I forgot to mark that. Let me mark that as well. And that is 135. At 135 it's equal to minus 1, and at 180 it's equal to 0. So that means right after 90 degrees this is what it looks like. Okay. And what do you think will happen if we keep going on? Notice the pattern over here. If we plug in 225, we get 1 again. So that means at 225, we get 1 again. And at 270, we will get infinity. So that means somewhere over here is 270. Here is 225. And then at 315, what do we get? We get minus 1. Sorry. At 315, we get minus 1. And at 360, we get 0 again. So what happens? The same pattern repeats. What does that tell you about tan? Repeat the natural period. Yes. So what does that tell you about the natural period of tan? Let me rephrase my question. Yeah, it's weird. Okay, that's one. But what about the natural period? What do you think about that? 180 degrees is the natural period. Good job. So if I ask you guys, let's list down the exact same properties as we did for sine and cos. What is the maximum value? It's not possible to determine what the maximum possible value is. Nope, it's not 1. It's not possible to determine what the maximum possible value is. It's infinity. Just like that, what is the minimum value? Negative infinity. Okay. Which is why we don't calculate the amplitude of tan. Okay, you will never be asked to calculate the amplitude of tan because it's impossible. You don't know what the maximum value is, you don't know what the minimum value is, hence you can't work out the amplitude. What you can work out though is the natural period. What's the natural period equal to? It's equal to 180 degrees or simply pi. And why is that? That's because you can see at 180 degrees, one cycle ends, and after 180 degrees, you have the exact same pattern. There you go. Yes, you could do that, but infinity minus infinity will be, what is that going to be? It's not going to be zero if that's what you're thinking. So because it's not a fixed value, therefore we can't calculate it. If it was a fixed value, we would have been able to calculate it. Okay. All right. Now, as always, take a good look at it. Let me know if you have any questions. We can check ASTC tan is positive before 90. Yes, I was just gonna come to that. Okay. Okay, so I'll explain exactly what Faiz has said. Do we have to draw them? Yeah, you do have to draw them. Okay, but it's not that difficult. Okay. Initially you might seem as if it's very difficult, but I'll give you some tips and tricks which will make it a lot easier. Okay. Tips and tricks, and mainly it's practice that will make it a lot easier for you guys. Okay. So can you explain what does a natural period mean and where do we use it? So natural period is basically the number of degrees it takes for a trigonometric function to complete one cycle. Okay. In the case of sine x and cos x, it's 360 degrees. In the case of tan x, it's 180 degrees. Now, where do we use it? So for example, if let's say you have to draw sine x, but the range is still 180. Okay, so if the range is still 180, and we now know from prior knowledge that it takes 360 degrees to complete one cycle, that means how many cycles are we drawing? We're drawing half a cycle. And if let's say the range is still 720, that means how many cycles are we drawing? We're drawing two cycles. Why? Because 360 degrees for one cycle, and then another 360 degrees, which means a total of 720 degrees for two cycles. Yeah, class will end at 6 or maybe 6:15 since we started a bit late. Yeah, yeah. Yeah, at 225 it's 1. And at 3:15 it's minus 1. Okay. All right. Now, so what we're going to do now is we're just going to play around with these graphs. Okay. Now, what do I mean by that? Not like physically play around with these graphs. We're just going to add something, we're going to subtract something and see what the overall impact is. Okay. So the basic shape, this is what the basic shape is. Now, when I say you should remember the basic shape, this is what I mean. So if I ask you guys what is the basic shape of sine, this is what you should be able to recall. Okay. And you should be able to recall that it starts at 0, ends at 360, at 90 it's 1, and at 180 it's 0 again, at 270 it's minus 1. Okay, so this is what I mean when I say you should be able to remember the basic shape. And then the basic shape of cos, this is what the basic shape of cos is. Maximum value is 1, minimum value is minus 1. One cycle ends at 360, half a cycle at 180, quarter cycle at 90, three quarters of a cycle at 270. And then when we're talking about tan, this is what you should remember about tan. Starts at 0, at 90 goes to infinity, at 180 it's back to 0. Shayan, I just said there is no maximum and minimum value for the case of tan because it's positive infinity and negative infinity. Okay, that's okay, nothing to worry about. All right, so when I say the basic shape, this is what I mean. Okay, and if you have these memorized, then that means 50% of the work. You've done 50% of the work. Okay, because everything will be applied to these shapes only. Okay, if you have sine x plus 1, if you have sine x minus 1, 2 sine x, 3 cos x, sine 2x, everything that we will do will revolve around these shapes only. Okay, so like I said, let's just make some small changes to the graph and see what do we get as see what do we get in the end. Okay, so I have a question. Yeah, go ahead. Say the horizontal values of these three graphs are going to remain same forever, because the amplitude can be changed, the horizontal cannot, right? For now, yes. Okay, but there are cases where we will have to change the step slightly. Like for example, even in the case of sine and cos, although we took 90 degrees as our step, but in some cases we'll have to change that to 45, 30. When we get to that, I'll let you know. Okay. Thank you. You're welcome. Okay, so we're going to do some examples, and while we're doing some examples, I'm going to redraw the graph of sine, cos, and tan and keep that in front of us. Okay, so sine, here we're going to draw the graph of cos, and here we're going to draw the graph of tan. Okay, so we're going to keep referring to them again and again. So the graph of sine, this is what it looks like. 1, minus 1, 180, 90, 270, 360. The graph of cos, this is what it looks like. 360. And your graphs have to be curves. Okay, they can't be made out of straight lines, and they can't be pointed. So keep that in mind. And then tan. That's good enough. Okay. All right. Now, let's say that you have to draw the graph of y is equals to sine x plus 1. And the range is from 0 to 360. So what do you think will happen? Sine x plus 1. So one way to go about it is that you can use the same table. Okay, you can plug in values, and in the end do a plus 1. Like for example, let's say we make a table. Okay, let's say we make a table and we start plugging in values from 0 to 360 with the interval of 90 degrees. Okay, so, and I will share a video with you guys. I would strongly suggest you guys to learn how to do this using your calculator so we can all save some time. And you can do it using your calculator. You're not going to lose any marks. So here's x, here's y. So let's plug in 0, sine 0, and in the end, don't forget a plus 1. So this is what it looks like. Right, I hope you guys can see my calculator. Yeah. So if you do that, what do you get? You get 1. So if you plug in 0, you get 1. Okay. And then if you plug in 90, so what is sine 90? Sine 90 is, you can see 1. But what will be sine 90 plus 1? It's going to be 2. So if you plug in 90, what do you get? You get 2. Using your calculator, so there is a table feature files in your calculator. I don't know if you ever used it in IGCSE or O levels, but what you can do is you can exactly program what function it is that you're trying to sketch and what values you want to plug in and what the difference should be. अभी बता दूं? चलें अभी बता देता हूँ. Okay, so pick up your calculators, press menu, and navigate to where you see table. So in this, you will see table at 9. This is what it's going to look like. So, figured out? Has everyone figured out where table is? Okay, great. Now, when you press 9, this is what you will see. You will see f of x equals to. Now here, I want you guys to write this down. Sine x plus 1. Sine, and in the bracket, use the alpha key to type x. Okay, so sine x, this is what it should look like. Then a plus 1. So this is what it should look like in the end. All right, done? If done, press equals to, then you will see g of x in this calculator if this is the one that you're using. Now, the good thing about this calculator is that you can program 2 graphs at once. Okay, in other calculators, in slightly less advanced calculators, you can only do 1, which is fine. We will never reach a point where we'll have to do 2. Even if we have to do 2, we can do it 1 by 1. Okay, so ignore g of x, just press equals to. I don't know how to write x, so press shift and press the bracket open key. Bracket close key, sorry. If you have one of these, okay, so you will see the alpha key is written in red. See where you have x and press alpha and press that key. So if you have one of these, it's alpha and then the bracket close key. That is where you will see x. See it? Okay, brilliant. So then when it comes to g of x, skip that. Okay, press equals to. Now you will see something like this, table range. You will see start and step. So where should we start? Look at the range and tell me, what do you think? Where should we start? 0. Very good. 0. Where should we end? 360. 360. Good job. What should be the step? 90. Okay. So the step should be 90 degrees. Press write 90, press equals to, and then press equals to again and wait for the magic. What do you see? 6. 6 baje. Okay. What do you see? 0. At 0, it's 1. At 90, it's 2. So what your calculator has done is it has plugged in the values for you and found out the end result. So that means when it's 180, it's going to be 1. And when it's 270, it's going to be 0. And then when it's 360, it's going to be 1. So you don't have to do this one by one to find out the corresponding values. Okay, you guys, honestly, in my opinion, you guys should know this already because this comes in handy in IGCSE and O levels as well. And I think in some other subjects as well, where you have to draw graphs, like, I don't know, maybe physics or chemistry. I don't know. Oh, I use this in IGCSE. It's giving 3 in y on 90. It shouldn't. It should give 2. Yeah, 2 is fine. It should be 2. Okay. So, how does this help? Now we know exactly what sine x is, what y is equal to when x is 0, and 90, 180, 270, 360. Okay, so now all you have to do is at 90, mark 2. Okay. At 180, mark 1. And at 270, mark 0. And at 360, mark 1. Okay. Now, how does knowing the basic shape help? Here's how it helps. Knowing the basic shape will tell you how you have to connect these dots. Okay, if somebody didn't know what the basic shape was, they might just join these dots using a straight line. And we know from prior knowledge, because we know what the basic shape of sine is, we know that we don't make it using straight lines. It's a nice and smooth curve. Okay, so this is what it should look like. There you go. Okay, so any questions? I hope everyone has managed to figure out the table feature using your calculator. How to use the table feature using your calculator. Okay, let's do another question. So this I want you guys to figure out. Y is equals to 2 cos x. Use your calculator. You're very welcome to use your calculator. Range is from 0 to 360. Okay. Draw the table, but then use your calculator to find out what the output values are. Okay. Draw the table, write down the values that you're going to plug in, and then the plugging in part for that you can use your calculator. 0, 90. Okay, great. We have the answer already. 270, 360. Okay, that's the benefit of being able to use a calculator. So at 0, it's 2. At 90, it's 0. At 180, it's minus 2. At 270, it's 0. And at 360, it's 2 again. Yes, so basically, yeah. Okay, in fact, wait a minute. Let's hold this for a minute. Yeah, let me come back to this and elaborate on what Josefa just said. So basically, if we compare this with the original shape of sine, how would you describe what has happened? This is what the original shape of sine is. So what exactly has happened? It has been translated. Okay, there has been a vertical translation of 1 unit. Okay, so there is a vertical translation of 1 unit. So this is how you compare the two. Back in O levels IGCSEs, we didn't use the menu thing and calculator to get the x value. We directly substitute y to get x. Yeah, of course, that's okay. But knowing that there is a feature in your calculator through which you can check your answer is always good. Okay, and getting the hang of that feature is always good, so you can check your answer and be sure that you've done it correctly. Okay. Yeah. So basically, there has been a vertical translation of 1 unit, and yeah, that's how you describe it. But we're not gonna dive deeper into transformation because that is something we will do formally when we're doing functions. Okay, now this will help you understand transformation in a lot more detail. Okay, a lot more thoroughly. Okay, so let's get back to this now. So now that we have the values and we know what the basic shape of cos is, we can put that together, put our knowledge together, and draw this graph. So it ends at 360. In between 0 and 360, we have 180. In between 0 and 180, we have 90, and then 270. So at 0, it's equal to 2. At 90, it's 0. At 180, it's minus 2. So that's right here. At 270, it's 0 again. And at 360, we're back at 2. So this is what it looks like. So, what are your thoughts? Easy? Difficult? Not bad? Easy? Yeah. So once you have like a good understanding of the basics, it becomes easy. And by the way, there's something I don't remember who mentioned, but there's something somebody mentioned about something about quadrants. Now let's circle back to the 4 quadrants and let's make more sense of what we did earlier. So if you remember, we said that there are 4 quadrants. In the first quadrant, all trigonometric functions are positive. In the second, sine is positive. In the third, tan is positive. And in the fourth, cos is positive. So now we can make more sense of this. You know why? Because if you look at the graph of sine from 0 to 90, is it positive or is it negative? Here it is, from 0 to 90. From 0 to 90, it's positive. And not only from 0 to 90, it's in fact positive from 90 to 180 as well, which is why we say that in the first quadrant and in the second quadrant, sine is positive. Okay, now you can make more sense of it because it's above the x-axis. And then let's see cos. Cos is positive from 0 to 90, so here's your first quadrant. And then when is it positive again? It's positive from 270 to 360. And what quadrant is this? Okay, sorry about that. Can you guys hear me now? Okay. So I'm just gonna keep my video off for I don't know, it's lagging every time I turn it on. Khair, anyway, so as I was saying, in the first quadrant you can see tan is positive, and it's again positive from 180 to 270. And what quadrant is that? That is the third quadrant. Okay, so like I said, now you can make more sense of what we did earlier, and I hope it makes sense to you guys actually. Okay, so next is, yeah, so I'm going to give you guys a few questions. What I want you to do is I want you guys to find out the corresponding y values, as in what it's going to be when it's 0, 90, 180, 270, and 360. And in fact, you're very welcome to actually draw them. And if you want me to check it, you can WhatsApp them, you can share them in the group, or you can send it to me directly. In fact, share it in the group, okay? So I can just give my comments on it. So try this out. Y equals to minus sine x. And then I want you guys to try y is equals to 2 sine x plus 1 from 0 to 360. Then I want you guys to do y is equals to 2 cos x minus 1 from 0 to 180. Okay, so keep your eyes and ears open. Then I would like you guys to do y is equals to 2 tan x minus 1 from 0 to 180 again. So, like I said, keep your eyes and ears open. So I'll give you guys 5 minutes to work this out. You guys can also use Desmos to check your answers. This app that I use very often, Desmos. Okay, Fawaz, I am looking at your graph. Can be slightly better, but not bad. Okay. As in the values are correct, but you can add some aesthetic appeal to it. That would be nice. the shape is also acceptable. So y equals to minus sine x. I'm just going to draw the curve here. This is what it should look like. And even though we are sketching, okay, but still do keep some sense of accuracy in mind. So for example, if let's say you're taking this to be 180, then try and at least make sure that the distance from 0 to 180 is more or less the same. It doesn't have to be correct to the nearest millimeter, but more or less the same between 180 and 360. Okay, so like for example, if let's say you draw something like this, let me show you an unacceptable version. So let's say this is 0 to 180, and then you realize you've run out of space, and then you call this 360. So this obviously doesn't make sense. Okay, so let me just fix this. So here 0, minus 1, 1, 180, 360. When does the graph go to the second quadrant? I mean, we are sketching on the first one. Oh, you mean here? It goes in the second quadrant when you have like a negative range. If let's say x is from minus 360 to 360 or minus 180 to 180, that is when you start from the left side of the y-axis. That's a good question. Okay, 2 sine x plus 1. So my suggestion is use the, Fawaz again, use the lines that you have and use them wisely. Like for example, look at what Shayan has shared. Yeah. So I would suggest that use one line to be 1 unit. Okay, like the way that I'm doing it. One line difference to be of 1 unit. Okay. So do that. That way you won't have like a lot to measure. It'll just make it easier. Doesn't matter if it's not if it doesn't have a lot of height to it, that's fine. Okay, the basic shape should be appropriate. All right, then we have y equals to 2 sine x plus 1. So again, use your calculator over here, plug in the values, see what the end result is, and then when you work it out, 2 sine x plus 1, this is what you should end up with. Just a minute. So it's going to start from 1, go till 3, and then come back, go till minus 1, and then back to 1. This is what it's going to look like. Now, obviously, it's going to be far more accurate and a lot neater than that. So let me just do it correctly. Here's 0. At 90, it's going to be 3. So 1, 2, 3. It's going to be somewhere over here. At 180, it's going to be 1. So somewhere over here. And then at 270, it's going to be minus 2. So that means somewhere over here. And then at 360, it's going to be, wait a minute. No, wait, at 0, it's not going to be 0. At 0, it's going to be 1. So at 360, it's also going to be 1. So this is what it's going to look like. Yeah. That. No, wait a minute. At 270, it's going to be minus 1. Sorry. Yeah, that's better. At 90, it's 3. Oh, yeah, it's 3. Sorry. This is 3. There you go. So for 5, we take 45 or still 95 is cos x, right? So you still take 90. Still take 90. I'll tell you when you don't take 90. It's when you have something to do with x. Like for example, if let's say you had cos 2x or cos 3x, that is when we change the step. So right now you don't have to change the step. And step also depends on the grid that's given to us. Okay, so step is dependent on two things. What the coefficient of x is, number one, and what the grid looks like. So at the moment, we don't really have a grid, so don't worry about it. When we have a grid, we will see that what we need to do to the step. Okay, so we're not too rigid about what step we take. Step at the moment, just stick to 90, but sometimes we change it, and when we have to change it, we'll get to that. So 2 cos x minus 1. Anybody who wants to share what that looks like? 2 cos x minus 1. Shayan, I have... Okay, I've already checked that. Abdullah, 2 cos x minus 1. Good job. And then for tan, let me double check. 2 tan x minus 1. That is correct. That is correct. Yeah, good job. Can you repeat your answer about why we take 90 and not 45? Because if you take 45, there's nothing wrong with that. You can take 45. Okay, you can take 30 as well. There's nothing wrong with that. But the thing is, taking 30 and 45 don't give us integer values. 0, 90, 180, 270, 360. In the case of sine and cos, taking values after every 90-degree interval gives us integer values. Like for example, if let's say you have to make a straight line. Okay, y is equals to 2x minus 3. And the range that you're given is from minus 1 to 3. So you're not going to take minus 1 and then minus 0.5 and then 0 and then 0.5. Instead, what you're going to do is you're going to go with integer values and not decimal values. Why? Because plugging in integer values will give you sorry, not plugging in integer values, plugging in decimal values will give you decimals, okay, which will be hard for you to mark on the grid. So that's why we go with integer values. So will there be an asymptote at 180? No, the asymptote will be at 90. That won't change. So at 2 tan x minus 1, you'll have an asymptote at 90. And then at 270, which is out of range. So when you're doing 2 cos x minus 1, let me first find out the values. 2 cos x minus 1, 0. End should be 180 and step should be 90. So here's what I'm looking at. At 0, it's 1. And at 90, it's minus 1. And at 180, it's minus 3. Yes, why is that? Why is it not the conventional shape of cos? That's because you're not making the entire graph. You're only making half of it. How do you know you're only making half of it? The range is 180. Yep, because the range is 180. If it was still 360, then you would have gotten an exact reflection of what you have already. Okay, but that's not the case. The case is that it's only till 180. So I thought step for tan is 45. Yeah, it is still 45. Step for tan is still 45. Okay. All right, nothing to worry about. Yeah, I don't know. I don't have the answer to that. I don't anymore. I used to back in O and A levels. I got pretty good at it as well, but then I stopped. What is that? Okay, I don't think I actually had one because we used to play in school only, school and within school tournaments and outside of that. So I don't know. Which school do you teach? I don't teach in a school anymore. I used to, but now I'm teaching online entirely. Previously, I was teaching at Nixer up until last year. Okay, so 2 tan x minus 1. Do we have the answer to that? 2 tan x minus 1. So here also use your calculator. Okay, make the most of the features that you have in your calculator. Here the starting would be 0, end would be 180, but the step is going to be 45. Okay, so at 0 you have 1. Sorry, at 0 you have minus 1 actually. So minus 1, here's a point. And sir, do you know about Sir Omar Khan? I've heard that name. So Islamia teacher, right? Yeah, I know him. Why? Acha, acha. I thought there was going to be a follow-up question. Here, so this is the first half. This is what it's going to look like. At 45, it's still 1. At 90, you get an error. So I've run out of space. Let me drag this over here, extend this slightly. There you go. Okay. And then at 135, you have minus 3. So 135 minus 3. And then don't forget, knowing the basic shape will tell you that after 90, it starts from negative infinity. So you're not just going to start from minus 3 and then complete it at 180. And what is it equal to at 180? It's equal to minus 1. So at 180, it's equal to minus 1. After 90, it's going to be negative infinity. And then this is what it's going to look like. Yeah, sir, you're right, Shayan. Sir Umar also used to teach in next row levels. Okay, so this is what it's going to look like. Now, this is a very half-hearted attempt. I should tell you guys, this is not what your graph should be. This was just to get the point across. Your graph should be, and it should be like a single stroke of pencil, not multiple strokes. Okay, just like how it used to be in IGCSE. If you're making a curve, okay, you're going to do it in one go without lifting your pencil. Not like this. Okay, this is unacceptable. Okay, you'll get the hang of it. You'll get the hang of it. Today is literally the first time we're doing graphs. Okay, so don't expect to get the hang of it from day one. Give it some time, give it some practice, and you'll get the hang of it. Okay. All right. So in the next class, what we're going to do is, so far what we have done is we have basically multiplied the trigonometric function with a certain value, positive and negative. We've added and subtracted. But there's one thing common in all the questions that we have done so far. What is that? Can anyone identify what that is? What is the one thing common in all the questions that we have done so far? And by the way, I will give you guys some homework as well. One. What one? Elaborate, Fawaz. I think you're onto something, but please elaborate. Plus minus 1. Okay, no. Sorry. That is not what I was looking for. Something else. There's a translation. Okay. Other than that, again, that's correct, but that's not what I'm looking for. My question is, in all the questions that we have done, yes, Janat, all the questions that we have done so far, there has been one thing common. That is, you have just x with the trigonometric function. You have tan x, cos x, sin x. Okay. There will be some cases where you have sine 2x or sine 3x or tan 2x. Okay, so we're going to see what happens when the coefficient of x changes, and the coefficient of x is something other than 1. Okay, so I'll give you guys like a trailer. So here we have y is equals to sine x, and see if you guys can pick up a pattern over here. Y equals to sine x. Let me change the range from 0 to 360, and let me change the step to 90. Okay, this should be in degrees. Minus 1 to 1. Okay. And then the range changes. Okay, yeah, I think again you're on to something. Let's see what happens when it's y is equals to sine 2x. Okay. Compare the two. The one in red is y equals to sine x. The one in blue is sine 2x. What do you think? I'll tell you the important values to compare. Compare this value with this value, and then compare this value with, wait a minute, compare these two values and compare these two values. The frequency changes, yes, the frequency changes, variation in wavelength. Okay, we're not talking about physics here, we're talking about math. But yes, what you guys are saying is correct. But the way that steps are different, yes, that is also correct. So basically what happens is, yeah, there's a horizontal stretch. So what happened is that all the x values actually get divided by 2. Okay, so previously you can see that it was 1 when x was 90. Now it is 1, but it's not 1 at 90 anymore. It's actually 1 at 45 degrees. Okay, and previously you can see that it was 0 at 180. Now this value has shifted over here. Now it is 0, but it's 0 at 90 degrees. Okay, and then previously you could see that it was -1 at 270. Now it is -1, but it's -1 at 135. So what's the relation between 270 and 135? 135 is half of 270. And previously it would end at 360 degrees. One cycle would end at 360 degrees. Now one cycle ends at 180 degrees. And how are they related? They're related because 180 is half of 360. Okay. Now, we will do this in detail, inshallah, in the next class. Let me answer this question. So, after you explain this, kindly inform the number before tan, cos, and sine is amplitude, but in 2 tan x minus 1, how 2 affects the graph. So, what happens is, in 2 tan x, all the values get multiplied by 2. So, previously, at 45, it used to be 1. Okay, now it is still 1 at 45. But that's because we have 2 tan x minus 1. Why? Because you multiply this 1 by 2. So it becomes 2 for a second. And then because of the -1, it comes back down. And previously at 135, it used to be -1. Now it is -3. Now why is that? Because you multiplied by 2. So -1, when you multiply it by 2, it becomes -2. And then when you further subtract 1 from it, that is why it becomes -3. So that's the change. Okay, so sir, anything plus minus something will shift the graph left or right, and what's the other thing? And amplitude will shift it up and down. Okay, so don't make these standard rules just yet. Okay, because we'll write down these standard rules formally when we're doing transformation. Okay, so right after trigonometry, we'll start transformation. So don't make these standard rules just yet. Okay, but one standard rule which you can make is that if you have something that's being multiplied by a trigonometric function, all the y values get multiplied by it. And if you have something that's being added or subtracted from in the end, then from all the values you add or subtract whatever it is that's being added or subtracted. Okay, so that's a standard rule that you can make. Okay, but that's more like common sense. Okay, so we will keep it till here only. In the next class, inshallah, on Thursday, we will do more of graphs. We'll do the complicated version of graphs, and then we will do the more complicated version of trigonometric expressions.